Hi guys, today what we're doing is we're going to look at reviewing area, surface area and volume. And today we're focusing on reviewing volume. So to calculate the volume of any solid, we use the formula V equals AH. This is where A is the area of the cross section or the base and H is the height of the solid from the cross section. Let's have a look at the volume of a cube. So to calculate the volume of a cube, we start with the formula V equals AH. And what we need to do is find the area of the cross-section base and then multiply it by a height. But for a cube, as every side is the same, we use the formula V equals S cubed. So let's have a little look at our cube here in our example. So for our cube, we have that every side is 9 centimeters. So we write out our formula let's go a little bit thicker, V equals S cubed. And then what we do is we substitute in our side length of 9. So V equals 9 cubed. And then we put that into our calculator. So 9 cubed equals 729. So V equals 729 centimeters cubed. Now when we're calculating volume, our units are units cubed. Now let's have a look at volume of a rectangular prism. So to calculate the volume of a rectangular prism, we again start with V equals AH. And what we need to do is find the area of the base rectangle, so that's this rectangle here, and then multiply it by the height. And for a rectangular prism, we can use the formula V equals LBH. This is where our LB is our area formula for our rectangle. So let's have a look at this example. So our formula is V equals LBH. This is where our length is 12, our breadth is 7, and our height is 4. So we substitute these values into our formula. So we have V equals 12 times 7 times 4. And we get V equals, we put this into our calculator, and we get 336 centimeters cubed. Now we're going to have a look at the volume of a triangular prism. So to calculate the volume of a triangular prism, we again start with the formula V equals AH. And what we need to find is the area of the triangle cross section. And then what we do is we multiply it by the height or length going away from the triangle. So we have our area of our triangle and then we multiply it by this length or height going away from the triangle. So for a triangular prism, I like to use the formula V equals a half BH, which is our formula for area of a triangle times L. So that's where our L is going back here. Now, I haven't put dimensions on here, so I will just quickly make up an example. So this is going to be 15 centimeters, our base will be 10 centimeters, and our height will be 8 centimeters. So we'll go V equals our formula, a half BH times L. So V equals a half times our base is 10 times our height of 8 times our length going back from our cross section is 15. So V will equal a half times 10 times 8 times 15, and we get 600 centimeters cubed for our answer. For our volume of a triangular prism, sometimes we get a right-angled triangle and we need to find the height or the base of the triangle using Pythagoras' theorem. So Pythagoras' theorem is c squared equals a squared plus b squared, and this is used to find the hypotenuse, so the side opposite our right angle. Or we use the formula a squared equals c squared minus b squared, which is just the Pythagoras theorem over here rearranged, which we use to find a short side. So if we look at our example here, we know that this length here is 15, and that is based because this length here is 15 and they are the same. We know that this length here is 6, which is our height of our triangle, but we do not know our base of our triangle. So this 15 is kind of irrelevant when it comes to finding the volume of our triangular prism. So what we need to do is we need to find this length here. So I'm going to call that A, And then we have this length here, which is our height or length going away. So if I just label all of those, so we have our B, our H, and our L. So if we look at our triangle, I'm just going to replicate it over here. So if we look at our right angle triangle, we have the side 6, 15, and our unknown A. Now, I'm just going to label this side is our hypotenuse, so it's C, and this side is our other short side, so it's B. So we're going to use the formula A squared equals C squared minus B squared in order to find the length of that short side using Pythagoras' theorem. So we have A squared equals our C is 15 squared minus our B, which is 6 squared. So A squared equals 15 squared minus 6 squared is 189, and A will equal the square root of 189. So A equals 13.74772708. And I'm going to round this now to the nearest whole number, which is 14 centimeters. So we now know that this side here is 14 centimeters. So now what we want to do is we want to use our volume formula. So V equals a half BHL and substitute in our values. So we'll have V equals a half times our base of 6 times our height of 14 times our length of 10. So V equals a half times 6 times 14 times 10. It doesn't matter which order you put this, because really this length here was our height and this length here was our base, but that's okay. And so we get volume equals 420 centimeters cubed. Now, to find the volume of a trapezoidal prism, we start with the formula V equals AH. We then need to find the area of the trapezium cross-section, so that is this area here, and then we multiply it by the height or the length going away from the trapezium, which is this length here on our diagram. So for a trapezoidal prism, we use the formula V equals H on 2, bracket A plus B times L. So let's have a look at our example. We have our height of our trapezium is 4. We have our top length A is 7. Our base length B is 9. And our length going away is 8. Now, in our formula up here, I'd just like to address that it's V equals AH, but because we already use a H for our formula for our trapezoidal, I like to change that H out to be an L. But as long as you know that it's the length going away from the trapezium, I feel like that helps people a lot more than thinking that it's the height, because otherwise people use this value again instead of this value here. So we have V equals H on 2, bracket A plus B times L. We substitute in our values, so we have H is 4 on 2, our A is 7 plus our B is 9 times our L of 8. Now we can just put this all into our calculator, so 4 on 2, bracket 7 plus 9, close our bracket, times by 8 gets us 256 meters cubed. For the volume of a cylinder, we again start with the formula V equals AH, and we need to find the area of the circular base and then multiply it by the height. So our circular base is pi r squared, or is how we find the area of our circle, and then we have our height. So for a cylinder, we use the formula V equals pi r squared h. So for this example, we're going to write out our formula V equals pi r squared h. Then on my diagram, I'm going to label my radius, which is 7, and my height, which is 22. I'm then going to substitute them in. So I have V equals pi times 7 squared times our height of 22. We put this into our calculator, so we have pi times 7 squared times 22, and we get 3,386.636881. Now, for a cylinder, a circle, whatever we are finding that involves pi, we should always write out the whole decimal before we round. Now, this question doesn't tell us what we should be rounding to, so I'm just going to round it to one decimal place. So we get our volume is 3,386.636881. 0.6 centimeters cubed. And because the question didn't tell us and I chose what to round to, I need to write in brackets that it's rounded to 1 decimal place over here. But by writing this line out here, if somebody was to look at this, you could see that I've rounded it to 1 decimal place, but it's still important to include this, and it's very important to include your calculator line to show your rounding. Now we're going to look at the volume of composite solids. Now the volume of composite solids isn't hard. What we have to do is we use the formula V equals AH. We want to find the area of the cross section. So our cross section here is this tent looking thing. Now our cross section is made up of 2 different shapes. That's why it's a composite solid. So we're going to have to find the area of each shape here and add them together, and then we just multiply it by the height, which our height is here, or our length going away. So our first step here, we have our formula V equals AH, but we need to find A. So A is going to be area 1 plus area 2. So area 1, I'm going to say, is this blue triangle here. I'm going to call that area 1. And then area 2 is going to be this green rectangle here. Area 2. So we want to find the area of area 1. So area 1 is a triangle. So triangle formula is a half BH. So area 1 will equal a half times, now the base of our triangle is this length here, which is the same as this length here, which is 12. So it's a half times 12 times our height of our triangle we have been given, which is 4. So area 1 equals a half times 12 times 4, which is 24. We then want to find area 2. So area 2 is a rectangle, and the formula for finding the area of a rectangle is LB, the length times breadth. So area 2 will equal 12 times 6. So area 2, 12 times 6 is 72. So now what we do, I'm just going to come up over here, is we have our area is equal to, actually I need a line going up. So our area is equal to area 1 plus area 2. So area equals 24 plus 72. So area equals 24 plus 72 is 96. And then what we do is to find our volume. Volume equals AH. So volume equals our area of 96 times our height going away from our cross section, or our length going away from our cross section, of 19. So 96 times 19 gives us a volume of 1,824 meters cubed. Lucky last, we have one more composite solid that we want to look at. So for this composite solid example, we have our famous L shape here. Now with our L shape, we have some sides missing. We know that this is 17, this is 21, these sides here are 25, so that's our length going back, or our height. I'm just going to label that. And then we have that this length here is 7. We know that this is 10, so we don't know two sides. We don't know what this length here is, and we don't know what this length here is. That's a little bit of a... Oh no, we know that this is 7, so we can find this. Phew! So, because this is 17, this is 7, this length here is going to also be 10. Okay, so how we got to 10 is we go 17, so our whole length of our shape, minus that little side bit. So 17 minus 7 gives us an answer of 10. Now we just need to find this side here. So we have 21 minus 10. So 21 minus 10 gives us an answer of 11. So I know it doesn't look like 11, but that is 11 there. So now for our area of our cross section, because that's what we're going to have to find, we first need to write out our volume formula. So V equals AH, and this is where area equals area 1 plus area 2. So for area 1, I'm going to split up my L shape into 2 rectangles, and my rectangles are going to look like so. I just realized I forgot to finish that side off. So area 1 is going to be my blue, like the last example, and area 2 will be my top rectangle, in green, like my last example. So area 1, how we find area 1, it's just a rectangle, so L times B, and it has dimensions, our length and our breadth, so it is dimensions 21 times 10. 21 times 10 is 210. Oops, I went for my 2 there instead of my equal sign. Is 210. Area 2 is our little green rectangle up here, and it has dimensions 11 by 7. So equal to length times breadth. Area 2 equals 11 times 7. So area 2 equals 77. So then we want to find our area by adding these two together. So area 1 plus area 2. So our area will equal 210 plus 77. So 210 plus 77 is 287. Then what we need to do is find our volume. So therefore volume equals AH. And so volume, our area was 287. Our height, or our length going back from our cross section, is 25. So 287 times by 25 gives us a volume of 7,100